Hello, good morning, good afternoon, or good evening. This is Ike Math greeting you, and I'm saying welcome back to my YouTube channel. I'm still doing the IBDP past paper questions on integration by parts. So the first video, I revised the key things you need to know. So if you haven't watched that video, please kindly first watch the video. I explained this formula, which is very important, okay? Whenever you're doing integration by parts, this is the formula you're supposed to be using. So which is UdV equals to UV minus integration of V du. Very important, okay? And I even explain in details when do you know that you are going to use the integration by parts. So it's always very important to pay attention to that, okay? So these are the examples I was explaining, trying to go through different ideas. Maybe I can view one thing here. So whenever we are doing integration by parts, there are two things we base on, okay? One is the Lie, which means the logarithmic function, inverse trigonometry, algebraic expression, or polynomials, then trigonometric function is an exponential. So the order is following this is the order we follow. So the U is all the time what you read to be U. I mean here, this is the formula. Integration of U dV equals to U V minus C integration of V du. So U is going to be with whatever you meet first. Okay? You can watch the video, the one I did first part, or when I'm doing the next questions, you're going to fully understand. So this is the first question I did. So it's a very good question. I did the question and we managed to do, and we got the final answer. So second question was that. So this is where we stopped. Let us dive in now in the next question we're going to do on integration by parts. One more time. The formula is U dV equals to UV minus integration of V du. Okay. Now that's the formula. That's the formula we're going to be using. So now, basing on Lie, okay, we have to identify. So before I apply it, maybe to help those who didn't watch the video first, the first video, which I would advise you to do, the first video I did on integration by parts. So why is it integration by parts? First of all, we are multiplying two functions. We are multiplying x squared and ln x. There are two functions that we are multiplying together. Now, that's the first thing. Another thing, we have two functions. If I rate one of them to be u, it's going to be easy to integrate the question and to differentiate, and helps me it's going to help me to be able to integrate the question. So can I follow yet? Now, I have a polynomial or a algebraic expression and the ln. Ln is logarithm. So that means my u is going to be ln x. Are we together here, guys? Very good. And then dv is going to be x squared dx. Is that okay? Now, after writing this is the formula I have to use. It is this one. dv, I've already got this one. So I have to get u and v. I have u. Unfortunately, I don't have v, so I need to find v. To find v, I have to integrate this. To get du, I have to do differentiation. I have to do the derivative of that. So derivative of du over dx is going to be, what derivative of ln x, guys? It's 1 over x, okay? Now, because I'm looking for du, I need to make du the subject. Good. It's going to be 1 over x dx, okay? I've got my du. So what is remaining is v, because I have u, I have dv, I have got du. So this time around, I'm missing v. So to get v, I have to integrate my dv. So v will be equal to, what's integration of x squared, guys? It is the x power 3 over 3, okay? Now, some students have seen from marking and everything, for years have been marking exams, IBDP exams. Sometimes they do plus C. Here, no need of doing plus C. You do it on the final answer, not at this point, okay? Pay attention to that. Now, what's the formula? U V minus V du. Now, can we substitute in our formula now? So what's my u? My u is ln(x). What's my v? It's going to be that. And remember, we have our limits, upper limits and lower limits. It's 1 to e. So that means it's going to be u is going to be that. So I write this first because it's multiplication, doesn't matter. Okay. Now ln x. Okay, that is my u and my v. Okay, all together here. So it's going to be my upper limit is e. Oh my bad, sorry. It's going to be e here, and then this is 1 minus integration of v. What's my v? This is my v. So it's going to be x power 3 over 3 x power 3 over 3 times the du, which is 1 over x dx. All together here? Very good. Now, when I reach here, what is remaining is just simplifying. You see this one? They'll cancel. So what I mean with, I will simplify this one. By the way, we can simplify. There's no problem about that. So when I put there e, I'll get e power 3 times ln e. What's ln e, guys? What's ln e? Do you remember? Ln e is the 1. So what am I going to get? Here, I'll get e power 3, write it very well for you. E power 3 over 3. Ln e is 1. Then, when I put there, this was 0, I guess. No, it was 1. Okay. Okay, so that means here I have to put there is going to be, if I put there 1, ln e is 1. So when I put there 1 here, it's going to be minus 1 over 3 because, sorry, can I check one more time? Let me check. Sorry, one more time. Let me substitute there very well. Okay, now let me start. So I'll put there e because I don't write a lot of things. So it will be e power 3 over 3. Very good. Now, times ln e, which is the 1. The next step, I'm going to put there 1. So, which is going to be 1 power 3 over 3. By the way, let me write it. There's no problem about that. So it's going to be 1 over 3 times ln 1. But ln 1 is 0. Okay, very good. Let me continue here. Minus integration of, can I take a half out? I mean 1 over 3 outside. Okay, what do I remain with here? I'm going to remain with the x squared dx, right? Very good. Now, here, what am I going to have? I'm going to have e power 3 over 3. Then this is 0 minus 1 over 3. Yeah, what is the integration of that? That will be x power 3 over 3. Is that okay? Remember, I had my limits. Huh? Remember my limits. My limits is still 1 and 3 here. Okay? Now, it's going to be this upper limit. Oh, the upper limit is e. It's e. Okay, some seconds, guys. Some seconds. Okay, I'm coming. Okay. Now, it's going to be, this is e here. Okay. Going to be e here. Okay, good. This is e. Okay, good. Now this is e. This is e 1. Okay. Now I'll get e power 3 over 3 minus. Can I put the e here? Minus 1 over 3 bracket e power 3 over 3, right? Minus 1 over, because 1 power 3 is 1 over 3, right? Okay, very good. Now, it's e power 3 over 3 minus, can I open the brackets? E power 3 over 9, all together here, plus, because this is minus, see how the sign will change, 1 over 9. All together, guys. Okay, what's remaining is just simplifying. Can we find the common denominator. If I find the common denominator here will be 9. Then this will be 2. 9 divided by 3 will give me 3. So this will be 3e power 3 minus 2. I mean minus e power 3 plus 1. So the final answer here will be 2e power 3 plus 1 over 9. Is that okay? Very good question. So integration, they said find the exact value. That means it's in calculator paper. So my answer should be this one. And you don't need to do plus C because this time we have limits. Okay? Very good. Next question. Now, find the area enclosed by the curve, okay, with this function, x-axis, and that one. So they said x-axis. So that means it will be integration 0 to square root of 3. Do you understand? And arc tan x dx, right? I hope you understand that. Very good. This is what we have to integrate. It's a 6-marker question, which you need is just to be knowing the basics of integration. Now, this question also, there's no any other technique of integration you can use apart from integration by parts. Why is it by parts? So, do you remember this, guys? Don't forget that. It will always help you. Okay? So, it is arrow is going to be what? Logarithmic function, inverse trigonometry, which is arc tan. So that means my u is going to be arc tan x, right? Arc tan x. Arc tan x. Okay? Good. What's going to be my dv now? My dv is going to be dx. Okay? Now, so from the formula, just remember the formula? It is the integration of u dv equals to uv minus integration of v du, right? Okay. Now, when you check here this time around, I've got u and the dv. So I need to get the rest. So we need to get the du over the x. We have to do the derivative. Check your formula booklet. What derivative of arc tan x is going to be 1 over 1 plus x squared, guys. Okay? Good. Now, what is the integration of that? Integration, whenever I integrate here, I'll get v as the x. Okay? Very good. Remember, we have the limits. So we apply the formula. It's going to be uv. So it's going to be x arc tan x. What were my limits, guys? My upper limit is square root of 3, and the lower limit is 0. Okay? The keyword here was underlined, and then this one. Okay? Now, minus integration of v is x times, I forgot to make the x the subject here, but you can see this. I'm at y. So it's going to be, du is going to be, this time is dx. So it's going to be 1 plus x squared dx. Because du, here I have du. So I have to make du the subject here. Okay, very good. Now, let me simplify this part and then I deal with this one. Now, when I put the square root of 3, I'll get square root of 3 arc tan square root of 3. Now, when I put there 0, this is the 0. So that means everything becomes 0. So it will be minus c is 0. Okay? Now, minus integration of this. Now, before I do that one now, you need to understand some few things. Maybe I can do this one here. Let me do it here. Okay? So we need to integrate that. Integration of x over 1 plus x squared. This one will be, the integration of this is u substitution. It can be by parts because you have a function on the top. So I have to direct u equals to 1 plus c x squared, right? That's what you have to do. So you see, if I do the derivative of this, will give me something to simplify. Normally, that's a trick of knowing it, that you can go with u substitution. So du over dx is going to be what? It's going to be 2x, right? So remember, for u substitution, you need to make the x the subject. For by parts, you make it u the subject. So the x here will be equal to du over 2x, right? Do you get that? Very good. Now, can I substitute in this now? When I substitute there, it's going to be integration of x over u, which is what? Into this one, 1 plus x squared is u, right? Good. Times the du over 2x, right? Very good. Now, this x cancels with this. So what am I going to remain with? This is going to give me, what does it give me? It's going to give me 1 over 2 integration of 1 over u du, right? So which is the 1 over 2 ln u. Now, what is the u? Do you remember what is u? This is 2, guys. Remember what did I call it to be u? So it's that one now. Fast forward, that means it will be a half ln 1 plus x squared. Okay, that is what I've got here. Can put that even your limits. Okay, now if that's the case, so I'm going to write 1 over 2 here, and then I write ln 1 plus x squared, and now I need to bring my limits. Remember what were my limits, guys? My limits were 0 and square root of 3. Upper limit square root of 3. And lower limit is 0. Very good. Now, let me sort out that. So, what is tan inverse of square root of 3? Guys, that's pi over 3. Do you remember that? It should give you that. I hope you remember. Right? It should give you that. Okay? So, I'm going to have square root of 3. That is the pi over 3. Tan inverse of this is 3. Tan inverse of square root of 3 is pi over 3. Minus, can I go with that? 1 over 3. Can I put the square root? That is the square root of 3 squared is 3. So this is ln 4. So it's going to give me bracket ln 4. Do you get that? Because it is square root of 3 squared. That is 3 plus 1. Now, can I put there 0? When I put there 0, it will be 0, which will give me ln 1, which is the 0. Is that okay for everyone? Very good. Okay. Now, close the brackets here. Now, okay. So, what do I get here now? It is the pi square root of 3. It doesn't matter the way you write it. Square root of 3 over 3. Okay. What about here? Here, I can tie up. The question is over. But this means the ln 4 power half, right? Because if you have a number here from rules of logarithm, this one you can take it up. What's square root of 4, guys? 2. So my final answer here will be pi square root of 3 over 3 minus square root of 4 is 2, so minus the ln 2. That is the answer for non-calculator paper. For paper 2, you can type this one in your GDC and then you get the answer. But for non-calculator paper, you are going to leave your answer as this without making any mistake. Is that okay, guys? Okay, very good. So I've done 2 questions by parts, using integration by parts. So I still have more 2 questions to do. Very interesting question. This one, very important. Special case by the way. Special case, okay? Very good. I'm going to do that one in the next video. I can stop from here. Thank you for listening, and thank you for paying attention. EK Math, we love mathematics.